Last week, we looked at the nuclear fission reaction, and one of the real concerns about the nuclear fission reaction that people have is regarding the design of the nuclear reactors. Are they really old? Are they still unsustainable? Are we building something for the future? Are we improving the safety of people inside and also people living around the nuclear facilities? How about the waste disposal? And how does nuclear actually compare with fossil fuels like coal and natural gas? How does it compare with solar and wind? All that we're going to be seeing today. The disaster that took place at the Fukushima reactor in Japan gave us a rude awakening about what could go wrong in a nuclear plant facility. So what it actually took was the fourth largest earthquake and 40 foot of tsunami waves that followed it to make the design flaws actually apparent.
Well, the perception was that there was a very minimal residual risk of a tsunami or earthquake that would overwhelm the power systems of a nuclear power plant. It was considered extremely small. And so the Fukushima Daiichi plant did not have a plan for a total wipeout of electric power and total wipeout of backup power. It didn't have that plan, and it wasn't thought to be really necessary. But some people thought, gee, in the next generation, maybe we should consider putting that equipment into the plant.
The US Department of Energy initiated the Generation 4 program in 1999. So these are the next generation reactor designs that have far more safety features than that are present in the older reactors. So they have duplicate emergency cooling systems to prevent overheating. They have power generation backup if in case if anything happens. And also they use alternative liquids or gases other than water for cooling that prevents the risk of creating hydrogen. To give credit to some of the nuclear reactors, they have started putting in place robust safety measures and policies in place to prevent further nuclear disasters. Several safety measures have come up against earthquakes. Nuclear operators are monitoring environmental radiation around their facility. They're even collecting environmental samples to confirm there is no harmful effect on the surrounding environment. And if you look at actions taken against flooding, they're really worried about another tsunami type event happening with 40-foot waves entering. So they are installing additional permanent emergency power supply units on higher ground. They're constructing coastal levees and large capacity seawater pumps. Study after study in top scientific journals has published that nuclear power plants are far and away the safest way to make reliable electricity. And you can find plenty of graphs like these out there in journals. One of them that I picked up, it shows the deaths per terawatt hour in the y-axis and the different sources out there. You can see that coal is by far the leading source of deaths per electricity generation just because of the fly ash and the air pollution that it creates. Coal followed by petroleum are the top two causes of deaths. Scientists actually did a study on estimating the radiation doses ingested by people living near the coal power plants, and they wanted to compare it with, the nuclear radiation itself. And at one extreme, they actually found that the fly ash radiation in the bones of individuals are around 18 millirems. Millirems stand for measuring the dose of ionizing radiation, and they found that the coal power plants emitted 18 millirems of radiation compared to nuclear plants that emitted only 3 to 6 millirems of radiation. So coal power plants are 3 times more deadlier than nuclear power plants just from a radiation standpoint alone, because of the coal ash that flies around when coal is burnt. The other thing from coal, of course, is the toxic pollutants that it produces. That damages the ozones. There is heavy metals, arsenic, and aerosols that is present in burning of coal, and these actually kill about 7 million people annually through air pollution. Nuclear fuel is very energy dense, so very little of it is actually required to produce immense amounts of electricity compared to other fuel sources. As a result, a very small amount of waste is produced. If you actually look at this chart, what it shows you is that only 3% in terms of volume of waste is generated through the fuel alone, and the rest 90% is through tools and work clothing, gloves, those kind of items. When most people talk about nuclear waste, they're actually referring to the fuel that's being used in the reactor once. And this is what we saw as the high level radioactive waste. Now, the concerns about the high level radioactive waste is that it is hazardous, it can produce fatal radiation doses even during short periods of direct exposure. So typically in every fuel reactor, the nuclear fuel is used to produce electricity for about 5 years. Then it's removed and safely stored temporarily as dry or wet storage. Now, what happens after that is the point of contention. Some countries decide to go for permanent geological disposal sites. Countries like the US, Australia, Argentina, Belgium, they all have deep geological disposal sites as the preferred option for nuclear waste management. Many countries like France, Japan, Russia, UK, etc., have decided not to go for deep geological sites, and what they end up doing is actually reprocessing the spent fuel. They convert the fuel into an insoluble solid waste form that will remain stable for many thousands of years. And this process is normally called as a vitrification process. So what happens is that they get the fuel from the reactor, they convert the fuel into a molten glass form, and then they actually pour the molten glass into a stainless steel canister. It's about usually like 4 feet high, and then they send the canister for storage and final disposal. But the bigger picture is that nuclear waste has not killed anybody so far. So, why doesn't the majority of the population not like nuclear technology? The answer to this question is the three major accidents that have happened in Fukushima, 3 Mile Island, and Chernobyl disasters. A lot of long term fear has been instilled in people, and that is not because of the accident itself, it's because of the overreaction to the accidents. Governments have not reacted in the right manner, they have evacuated a lot of people needlessly, and they haven't believed in science exactly. A lot of anti-science activists have popped up following the accidents, and a lot of fear mongering is going on in the media saying that nuclear energy is actually killing a lot of people. A lot of memories are associated with nuclear weapons used in World War II. Many people think that nuclear weapons also behave in the same way as nuclear technology, and hence nuclear technology should not be allowed. The simple answer to that is that it is physically impossible for the reactor core to be designed in a way like a nuclear weapon, and so it cannot explode in a way that the nuclear weapon does because of the chemical composition. The actual reality is that nuclear energy does not produce the same amount of greenhouse gas emissions as fossil fuels does, and nuclear energy is becoming more and more safer. The reactor designs have improved, and a lot of R&D is going on. A lot of collaboration is also going on in finding permanent sites to dispose of the nuclear waste itself. If you balance out the concerns with the benefits of nuclear technology, nuclear energy is in fact potentially a very good source of energy that we should be using more of in the future.